Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. Welcome again. That is the second period, or you can say that the second lesson of your chemistry. If you remember that yesterday we learned about chapter number 17, reversible reactions. Okay, in which I explain you there are different types of reactions, chemical reactions, in which what happened, reactants are converted into products. For example, here you can see a simple chemical reaction in this. What happened? Like here, if you see, for example, this A plus B, these are two reactants. When they react during a chemical reaction, the product is formed that we name as C plus D. That was a simple chemical reaction that we learned yesterday. Second thing, we also saw that if this thing, here you can see this arrow, how it's become reactant to product you formed here in this way. Now, if the arrow is in this side, two half arrows, sorry for this, like this, yeah. So then we say that A plus B, again reactants, they convert into product like C plus D, maybe any product. But at the same time and during that reaction, reactants converts into products, and then the products again react with one another and gives you back reactant. That is a simple reversible reaction that we studied or discussed yesterday, in which we also learned about a simple chemical equation in which we know about this, the blue hydrated copper sulfate. When we heat this, water goes out and it becomes a white color or white colorless, you can say that a compound we get. After addition of water, again we get the blue color of this copper sulfate. So till here about reversible reaction. If you have any question, you can type in chat. Otherwise, you should type no. Thank you very much. In the chat, thank you, Basil, Abdul Aziz, Raid Majid, Daud. Thank you very much, the student. They are participating. Ibrahim, Marwan. That's great. Excellent, my dear. Okay, now let's move today topic. So let's start on this one. For this, you need to open your textbook page number 221. 221. This one. Here we're going to discuss about the more reversible changes or the examples, or you can say that on this page we're going to learn about the examples and one more thing that we name as indicator. Before to start this reaction, here at the top of this you can see that indicator changing colors are also examples of reversible changes or reversible reactions. Before to dive in this topic, you should know about the indicator. What is an indicator? So for this, I'm going to share the slide with you. Here you can see this is the definition of indicator, or you can say that what are indicators. So I would like from here, Abdul Aziz, please can you read from here what are indicators?
What are indicators? An indicator is a simplified observable and measurable characteristic that can be used to show changes or progresses a program is making toward achieving a specific outcome.
Very nice. It's a simple definition in which what it's going to tell us, indicator is a specific. It's not common. You can say that like enzymes, they are specific. They have specific properties. You can use only a specific indicator for a specific reaction. observable and measurable. You can observe the changes may be due to color or due to any sense, and also measurable. You can measure it easily. Now, characteristics that can be used to show changes or progresses a program is making toward achieving a specific outcome. For example, indicators you can use in a reaction to find the results, to find the changes. Next, please, Hussein, can you read from here? An indicator is a
An indicator is a substance that changes color or acidic and basic medium, and indicator shows one color in an acidic medium and different color in a basic medium, so that they are both indicators. There are different styles of indicators.
Okay, so what it tells us, actually the indicators basically we use here in chemistry, especially to find out acidic and basic, you know, and acid and base. The color that shows us when we're going to add the indicator, it will change its color when the solution acidic, or either the solution will become a basic solution. So it's going to change its color. Understand? Till here, any question, you can raise your hand, otherwise type no in the chat. Everyone, please. Okay. Now let's see here a couple of examples of indicators. Yeah. Indicator derived from natural sources are called natural indicators. You can say as litmus, red cabbage. These are the natural sources of indicator. Indicators prepared in the laboratory are called synthetic, meaning to say which you're going to prepare, synthesize or synthetic indicator. The example is phenolphthalein. Don't forget this term, okay? Or you can underline or highlight this one, phenolphthalein. Okay, we deal with this indicator a lot, and also about the litmus. This also two types, one is natural and second is prepared or synthesized, that we work with them. Thank you very much, Mr. Ahmad Ali. Okay, so here in front of you, we have a simple assessment, and you can see this an alkaline solution. It's mean not an acidic. You can say that as a basic solution. Ahmad, please concentrate on the screen or even book. Thank you very much. Now, color of phenolphthalein indicator. You can see here in the flask or in this conical flask here, its color is almost, what color here? Type in the chat. Anybody if know the color? What this color? In chat, please. Not red. It's almost here due to the printing, but yes, that's correct one. Abdullah Salim, well done, my dear. He mentioned that its color is pink. Its color is pink. So it's pink color. When you add this one, so after it will convert it into white. The reason of this conversion of its color, let's see a simple assessment related to indicator, and we will understand more about this. Phenolphthalein indicator is not affected by the pH of the solution. Keep it in your mind, and this statement is true. First thing. Second, the phenolphthalein indicator changes color close to the end point or point of neutralization, which show the end point of the titration. Titration is a process, my dear students, in which we're going to let react both acid and base. The reaction between acid and base that's happening in a process we name as titration. So that is also true. The third point here, when adding acid to base, the phenolphthalein indicator change color from colorless to pink at the end of the titration, not at the end. You know that here itself, it's the end point. As it's going to come neutralization, it will change. So this option is not correct. So this statement is false. Now come back to your textbook again, 221. Here in front of you, hope all you understand very well about the indicator, especially phenolphthalein. So let's start from here. There are one color in acid and other color in alkali, or you can say that as base. Can you remember the color of litmus in acid and in alkali? If anybody knows, please type in chat. Each look to experiment 10.1 on page number 125. You are trying to neutralize an acid solution with alkali. Which indicator did you use? Why don't you need to start all over again if you add too much acid? Now in front of you here, try to understand from the picture that in front of you, this alkali with universal indicator, maybe light purple color or pinkish color here. When you're going to add acid in this beaker, its color will change as red or brownish color. Its clear image will be on your book. Now, after adding with universal indicator, in this one, when you add alkali, it will again go back to its previous color. What it means? So this is a simple type of reversible reaction. Understand? Whatever we get from reactant to product, and then we go back from product to reactants. So I would like Mr. Shoaib, Abdullah Shoaib, can you please read this experiment 17.2? You don't have book? Yeah, please open your book because here it's a little bit blur the image. That's the reason. Page number 221, 221. Experiment number 17.2.
Experiment 17.2. Changing color.
Phenolphthalein indicator.
Is colorized in acid and pink purple
Underline this. Underline this statement. If you have your books, the color of phenolphthalein is colorless in acidic or acid and pink purple in alkali. I told you, explain you two colors, maybe pink or purple. So it tells you here in alkali, its color may be pink to purple or between them. Okay. And in acid, it become colorless. Yes, please.
Add some to a paper of water. Rinse another paper with sodium hydroxide solution. The second paper looks empty, but it now has drops of alkali in it.
Actually, the hydroxide, the sodium hydroxide is an alkali. Okay, keep it in your mind. This NaOH is an example of alkali. Yes, please.
What happens? Why? A third paper has a little light
Dilute acid in it. Pour your solution into the beaker.
What happens? Why?
Okay, look here. Now come back to your diagram. You can easily see that in this diagram, this one beaker, this is the second and the third. What you done first, add some phenolphthalein in beaker of water. Okay, few drops. Then rinse another beaker with hydroxide. This is the solution of sodium hydroxide that you rinse. Then you add the phenolphthalein, or you can say that the little water in that beaker, in sodium hydroxide beaker, its color become pink or purple. When you go back or you add or pour this liquid back into the acid containing beaker, it become again colorless. Okay, because this is the property, or you can say that this is the representation of that indicator phenolphthalein in acid and in base. So here is another example of a reversible reaction. So let's start to see this one. For this, I'm going to request Mr. Ahmad, can you read please? When ammonia and hydrogen chloride ammonium chloride experiment. Okay, first is tell you a simple experiment. What happened in front of you here? Another example of reversible reaction. When ammonia and hydrogen chloride gases meet, they react. We know very well. Okay, then they form a white cloud of ammonium chloride. Then in the next experiment, it's going to tell us how we go back or how we can reverse this experiment or reverse this reaction. It's not impossible, very easy. So please, can you read please? Yeah.
Okay. Experiment 17.3. Heating
Ammonium
chloride. A reversible reaction. Gently warm some ammonium chloride in a boiling
you can see here, yani it's telling you gently warm, not quickly heat. Keep it in your mind, this thing. You warm it slowly, gently, not make a high flame and put your test tube on the flame. No, it will be not the proper way. So gently warm some ammonium chloride in a boiling tube. This one here, you can see that. Now next please, Adil, Ahmad Adil, I think. Yeah.
What do you see on the cool part of the tube near the top? How can you explain what happens in the tube?
So first of all, you're going to understand this reaction. What's happening? You can see here, when you heat, ammonium chloride gathered at two places. One is here and second is here, because you close the mouth of this test tube with wool. Okay. Now, next, Mr. Karam. Karam, can you please read from here? Ammonium chloride. Thank you very much. No problem. Okay, that's great. Now what happened? You can see in the equation here, word equation and the formula of chemical equation, both are here. This is the formula of ammonium chloride. NH4Cl. S represent here solid. What it means? In the test tube at the bottom, you have solid ammonium chloride in solid state. When you start to heat, the ammonium gas, that is NH3 plus HCl gas, it's coming out, hydrogen chloride. But you close this one, you will not let it to go out. So then what happened for this? Let's go back to the slide. After this here, the examples of reversible reaction and what we name this reaction. It is a special type of reaction. We name this as thermal decomposition of ammonium chloride. So you can see here the arrow, first thing that represents you, it is an example of reversible reaction. It is an example of reversible reaction. Second thing, an ammonium salt can be made by reacting ammonia with an acid. Look, when they both react, this ammonium gas and this NaCl gas, it gives back you again ammonium chloride. So same thing happen, my dear, when you close this the test tube, these gases again react one another and they will give you back the reactants. So till here, if you have any question, my dear students, you can raise your hand or otherwise type your question. I'm really happy to reply you. Okay, that's great. Excellent. Okay, after this, here it's a simple reaction. Ammonium chloride decompose back into ammonia and chlorine gas when heated. If you close this, if you didn't close, they will escape. Okay, you can't get back your product. Now, the last part of today's lesson, that is the class assessment. I gave you 5 minutes. So everyone who know the answer, please type in the chat. There are 2 questions in front of you. If you want to take help, you can, but not mine. I gave you 5 minutes. Everyone, please take your time, understand the questions, read them, and then text me your answers. Please don't speak. Everyone, please. So the first question here, phenolphthalein change color in. Where it's changed? In acids, alkalis, water. Please, if you know, type in the well done, Mr. Ahmad Ali. Ahmad Ali, your answer is correct. Well done, very nice. And Ahmad, please, I want to know the second answer also. The first students who tell me the correct one, he is Ahmad Ali, mashallah, very nice. So dye which change color over a specific pH range is. What the answer of this question? Everyone, please, mashallah, here we are now more than 24. Okay, if you add me, then 25. So please try to find the answers. And if you know, type in the chat. No, Abdullah Salim, your second is not correct. Raid Majid, no. I'm waiting for your replies, please, everyone. Sorry? I kick you out. No, this is not correct. Who here? This is Daud. Daud, that is not correct. Second is not correct. Okay, Ahmad Ali sent the second answer. Yes, Ahmad, your both answers are correct. Very nice, excellent. How we know the answer? Okay, I will. I'm here. Well done, Mr. Ahmad Ali. Your both are correct. Abdul Aziz, first. Yahi, write the number and then type the answer, not like this. I don't know what first. Okay, this Abdul Aziz, yes, this answer is correct. It's better you just type question number and A, B, C, anything. That's great. My answer is correct. Abdul Aziz, Tariq is correct. Try to find. Well done, very nice, excellent. Yes, sir. Did you send? Yes. Ahmad Adi, let me do. Yeah. Yes, it's correct. Well done, Mr. Abdullah Dawood again. This question number 1? Yeah, it's correct. Now it's correct. Maybe you could take help from Google, yeah? Because you're taking a lot of time. Not to you. Yeah, I know from the book, but the student, they don't want to open the book. So, okay, now I'm going to help you. Look, as you know very well about the phenolphthalein, it's change color in alkali. Okay, so this is the first correct one. And second, that we know, okay, okay, no problem, Ahmed, you can. Acid base indicator, yeah. No. This alkali here dyes will change color over a specific pH range. That acid base indicator. That's the correct one. So this is all about today's lesson. Till here, my dear students, if you wanna ask anything, please you can type your question. Otherwise, you will type no. So just a minute.